Hey everyone, and welcome back to the channel. Have you ever wondered how companies like Netflix recommend your next binge watch, or how Google Maps finds the fastest route to your destination? It's not magic, it's data science. We are living in the age of data, an era where information is more valuable than ever before, and those who can understand and interpret it are leading the charge. If you're feeling a bit lost in the sea of buzzwords like AI, machine learning, and big data, and you've been thinking about a career that's not just exciting but also future-proof, then you're in the absolute right place. Today, we're not just scratching the surface, we're diving deep into a comprehensive roadmap, your ultimate guide to becoming a data scientist in 2026. This isn't just theory, it's a practical, step-by-step path designed specifically for beginners, to navigate the exciting world of data. So, grab a notepad, settle in, because your journey into data science starts right now. So, what exactly is data science? In its simplest form, data science is about extracting knowledge and insights from data. Think of it as a multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. It's not just about crunching numbers. It's about asking the right questions, finding meaningful patterns, making predictions, and telling compelling stories with data. Imagine a doctor using patient data to predict the likelihood of a disease, or an e-commerce platform analyzing your browsing history to suggest products you might love. That's data science in action. It sits at the intersection of three core areas: mathematics and statistics, which provide the tools for analysis, computer science, which gives us the power to process vast amounts of data, and domain expertise, which helps us understand the context and business problems we're trying to solve. Without understanding the context, data is just a collection of numbers. With it, it becomes a powerful tool for change. Why jump into data science now, especially with our 2026 roadmap? Simple, the demand for skilled data professionals is exploding, and it shows no signs of slowing down. Major publications consistently rank data scientist as one of the best jobs globally. Companies across every sector, from healthcare to finance, entertainment to manufacturing, are collecting vast amounts of data and desperately need people who can turn that raw data into actionable insights. This isn't just a trend, it's a fundamental shift in how businesses operate. A career in data science offers incredible job security, competitive salaries, and the exciting opportunity to work on cutting-edge problems that genuinely impact the world. You could be helping develop personalized medicine, optimizing logistics for global supply chains, or even creating the next generation of AI assistants. The skills you gain are highly transferable, opening doors to diverse roles like machine learning engineer, data analyst, business intelligence developer, and more. This is truly a career that lets you shape the future. Okay, enough with the hype, let's get practical. Our 2026 roadmap is structured into three clear phases, designed to take you from absolute beginner to a job-ready data scientist. We'll start with Phase 1, Foundations, where we'll build the bedrock of your knowledge, covering essential math, programming, and data handling skills. Next, we move into Phase 2, Core Data Science, diving into the heart of what data scientists do, from cleaning and exploring data to building predictive models with machine learning. Finally, Phase 3, Advanced Topics and Specialization, where you'll explore more complex areas and learn to effectively communicate your findings, setting you apart in the job market. Remember, this isn't a race, it's a journey. Consistency and hands-on practice are your best friends. Don't get discouraged if something feels challenging, every expert was once a beginner. We're here to guide you every step of the way. Let's break down each phase in detail. Our first stop in Phase 1 is mastering the fundamental language of data, math and statistics. Now, before you panic and close the video, let me assure you, you don't need to be a math genius. You need a solid working understanding of key concepts. Think of it as understanding the rules of the game. For mathematics, focus on basic linear algebra, which is crucial for understanding how many machine learning algorithms work under the hood, and a bit of calculus, primarily for optimization techniques. Don't worry about complex proofs, understand the concepts. But where you really need to shine is statistics. This is the backbone of data analysis. Start with descriptive statistics, learning about measures of central tendency like mean, median, and mode, and measures of spread like variance and standard deviation. These help you summarize and understand your data. Then move to inferential statistics, understanding probability distributions, hypothesis testing, and confidence intervals. These allow you to make educated guesses about larger populations based on your sample data. Resources like Khan Academy, Crash Course Statistics, and introductory university courses are fantastic starting points. Remember, the goal isn't to become a theoretical mathematician, but to understand the principles that drive data interpretation. Next up in Phase 1 is arguably your most powerful tool, programming. While several languages are used in data science, our 2026 roadmap strongly recommends focusing on Python. Why Python? It's incredibly versatile, has a huge ecosystem of libraries specifically designed for data science, and a massive, supportive community. It's also relatively easy for beginners to pick up. For those who prefer a more statistical-centric approach, R is another excellent choice, especially popular in academia and research. But if you have to choose just one to start, make it Python. Begin with the basics, variables, data types, control flow, if/else statements, loops, and functions. Once you're comfortable with the fundamentals, dive into Python's essential data science libraries, NumPy for numerical operations, Pandas for data manipulation and analysis, think spreadsheets on steroids, and Matplotlib or Seaborn for data visualization. You'll be surprised how quickly you can start performing complex analyses with just these tools. Online platforms like Codecademy, DataCamp, and Coursera offer excellent interactive courses to get you started with Python for data science. Practice writing code daily, even if it's just solving small problems. The final piece of your foundational puzzle in Phase 1 is SQL, or Structured Query Language. Almost all real-world data lives in databases, and SQL is the universal language used to communicate with them. It allows you to retrieve, manipulate, and manage data stored in relational databases. You absolutely need to be proficient in SQL to extract the data you want to analyze. Think of it, a data scientist needs to query databases to get specific information, perhaps all sales data from the last quarter, or customer demographics from a particular region. Without SQL, you're stuck. Focus on core SQL commands, select to retrieve data, from to specify tables, where for filtering, group by for aggregation, join for combining data from multiple tables, and order by for sorting. These commands will empower you to pull exactly what you need from vast datasets. Many online tutorials and interactive SQL playgrounds can help you master these skills quickly. SQL might not be as flashy as machine learning, but it's an indispensable skill that will serve you throughout your data science career. Now that you have a solid foundation, we move into Phase 2, Core Data Science, starting with a crucial, yet often underestimated, step, data collection and cleaning. In the real world, data is rarely perfect. It's often messy, incomplete, inconsistent, and full of errors. In fact, data scientists often spend 70 to 80% of their time just cleaning and preparing data. This involves tasks like handling missing values, dealing with duplicate records, correcting inconsistencies, converting data types, and removing outliers. Imagine you're analyzing sales data, but some entries have not applicable for price, or product names are spelled differently. You can't make sense of it until it's cleaned. You'll use your Python, Pandas, or R skills extensively here. Understanding various data sources, APIs, web scraping, flat files, CSV, Excel, and databases, is also key. This phase teaches you patience and meticulousness, skills that are highly valued because clean data is the bedrock for any meaningful analysis. Garbage in, garbage out, as they say. Once your data is clean, it's time for exploratory data analysis, or EDA. This is where you really start to dig in and understand your data. EDA is all about summarizing the main characteristics of a dataset, often with visual methods. It's like being a detective, looking for clues, patterns, and anomalies before you jump to conclusions. You'll use your visualization libraries like Matplotlib and Seaborn in Python, or ggplot2 in R, to create insightful charts and graphs. Is there a correlation between two variables? Are there unusual peaks or valleys in your data? What are the distributions of your variables? For example, if you're analyzing customer churn, EDA might reveal that customers who use a specific feature are less likely to leave, or that churn increases significantly after a certain period. This phase is crucial for formulating hypotheses, validating assumptions, and identifying potential problems or opportunities. It's where you start to uncover the hidden stories within your data and prepare it for the next exciting step, building models. This is often the part that excites people the most, machine learning. In simple terms, machine learning is about teaching computers to learn from data without being explicitly programmed. It's how systems get smarter over time. You'll start with the fundamentals, understanding the difference between supervised learning, where your data has labels, like predicting house prices based on features, and unsupervised learning, where your data doesn't have labels, like grouping similar customers together. Within supervised learning, you'll learn about regression algorithms, used for predicting continuous values, like predicting sales figures or temperature. Simple linear regression is a great start. Classification algorithms, used for predicting categories, like predicting if an email is spam or not, or if a customer will churn. Think logistic regression, decision trees, or k-nearest neighbors. For unsupervised learning, start with clustering techniques like k-means, which groups similar data points together. You'll primarily use libraries like scikit-learn in Python, which provides a fantastic array of easy-to-use machine learning algorithms. The goal here is not to build the most complex model, but to understand how these algorithms work, when to use them, and how to evaluate their performance using metrics like accuracy, precision, recall, and F1 score. This is where your foundational math and statistics really come into play. As you progress, in Phase 3, you might find yourself drawn to more advanced topics. Two popular paths are deep learning and big data technologies. Deep learning is a specialized subset of machine learning that uses neural networks with many layers to learn complex patterns. It's behind facial recognition, natural language processing, and self-driving cars. If you're passionate about AI, computer vision, or natural language understanding, diving into libraries like TensorFlow or PyTorch will be your next step. However, it requires more computational power and a deeper understanding of linear algebra and calculus. Then there's big data technologies. If you're dealing with datasets so massive they can't fit on a single machine, think petabytes of data, then you'll need tools like Apache Spark or Hadoop to process and analyze them efficiently. These are critical for roles in large enterprises dealing with truly enormous data streams. These areas are often specializations, and while exciting, it's perfectly fine to master the core data science skills first before venturing into these more complex territories. Don't feel pressured to learn everything at once. Focus on building a strong foundation, and then explore what truly interests you. This is perhaps the most overlooked, yet absolutely critical, skill in Phase 3, data storytelling and communication. You can have the most brilliant insights hidden in your data, but if you can't effectively communicate them to stakeholders, who often don't have a technical background, your work won't have an impact. Data science isn't just about analysis, it's about influence. This means learning to craft compelling narratives around your findings. How do you present complex ideas simply? How do you create visualizations that are not just pretty, but truly convey meaning? How do you answer the "so what" question? This involves mastering tools like PowerPoint, Tableau, or Power BI for creating interactive dashboards and presentations. It's also about developing strong presentation skills, clearly articulating your methodology, and confidently recommending data-driven actions. Practicing explaining your projects to non-technical friends or family is an excellent way to hone this skill. Remember, a data scientist who can tell a story with data is an invaluable asset to any organization. Learning theory is great, but to land a job in 2026, you absolutely must have a strong portfolio. Employers want to see what you can do, not just what you know. Think of your portfolio as your data science resume in action. Start with small projects that reinforce the skills you're learning. For example, analyze a dataset from Kaggle, a fantastic platform for data science competitions and datasets. Try to predict housing prices, analyze customer reviews, or classify images. Document your entire process, from data cleaning and EDA to model building and evaluation. Share your code on GitHub. This shows potential employers your coding style and problem-solving approach. Consider writing blog posts about your projects, explaining your methodology and findings in simple terms. This demonstrates your communication skills. Don't wait until you feel ready to start building projects. Start now. Even small, well-documented projects are better than none. Quality over quantity, always. This hands-on experience is what will truly solidify your understanding and make you stand out. The field of data science is constantly evolving, so continuous learning is not just a recommendation, it's a necessity. Thankfully, there's an abundance of amazing resources available. For structured learning, explore platforms like Coursera, Udemy, edX, and DataCamp. They offer comprehensive courses and specializations from top universities and industry experts. For deeper dives or specific concepts, look to textbooks or online documentation. YouTube tutorials and tech blogs are fantastic for quick explanations and practical walkthroughs. But don't just consume, engage. Join online communities like Stack Overflow, Reddit's r/data science, or local meetups. Network with other aspiring and professional data scientists. Follow influential data scientists on LinkedIn or Twitter. Listen to data science podcasts. The key is to stay curious, keep experimenting, and actively participate in the community. This isn't a destination, it's a lifelong learning journey, and embracing that mindset will make you a truly exceptional data scientist. So, there you have it, your complete roadmap to becoming a data scientist for beginners in 2026. We started by understanding what data science is and why it's such a hot career. We then laid out the three crucial phases: Phase 1, Foundations, covering math and stats, programming, Python, and SQL. Phase 2, Core Data Science, where you learn data cleaning, EDA, and machine learning fundamentals. And finally, Phase 3, Advanced Topics and Specialization, including deep learning/big data, and critically, data storytelling. Remember to actively build your portfolio with real-world projects and commit to continuous learning. This journey requires dedication, but the rewards are immense. The world needs more people who can make sense of data, and you absolutely have what it takes to be one of them. Take that first step, stay consistent, and don't be afraid to make mistakes, they are your best teachers. If you found this roadmap helpful, please give this video a thumbs up, subscribe to our channel for more valuable content, and hit that notification bell so you don't miss our next upload. What part of data science are you most excited to learn? Let us know in the comments below. Your future in data science starts today. Thanks for watching, and I'll see you in the next video.